we have to.
We'll finish this later.
So whatever you get for your mean, what was the mean? 1.34. Standard deviation sigma was 0.96. So then what the variance? Variance is sigma squared. So if I have sigma and I want sigma squared, I square what sigma is, so I take 0.96 and I square that. And everybody got 0.92?
Yes.
Great. All right. Great. That will do the next step. So your quiz, we'll do that next class. The rest of quiz problems, the quiz part on problem 3, we'll do that next class. So you guys get some practice. You folks get some practice. Not the same night, but like a few days later. Expectation again. Remember, the expected value is the mean of the probability distribution. So let's do problem number 14 on the worksheet with me. So that's the next page. I believe it's also not problem number 4, is it? It's problem number 5?
Yeah.
How about a reader? Diego, read for me.
Life insurance, a 35.
Oh, sorry.
A 35-year-old woman purchases a 100,000 term life insurance policy for an annual payment of $360 based on the period life table for the U.S. government. The probability that she will survive the year is 7.0. Find the expected value of the policy for the insurance company.
Great, thank you. So find the expected value for the insurance company. So from the perspective of the insurance company. So if you're the insurance company, what are the possible outcomes of this situation? She can die or
She could not die.
or survive. Yep. So those are two. So those are two possible outcomes. Those are the only two possible outcomes. So we'll have my X is she lives or dies. That's fine. I guess we can. Yeah, hopefully it's not saying fun. Or we'll say doesn't. All right. Well, just people are having a hard time this year. It's been a very hard year. Okay. So probability of X. So if you're the insurance company, who's ever heard of insurance? Life insurance. Oh, good. This is so weird. Those of you who haven't, have you just heard of like the movie where the wife kills the husband for the life insurance policy? Right? What that means is he dies, she gets money. Okay. So here, if you are the life insurance company, what does it mean to you if she lives? Or what does it mean to you if she doesn't live?
You have to pay money.
You have to pay money. If she does not live, you pay money. How much do you pay?
$100,000.
$100,000. So do I get $100,000 if I'm the insurance company, or do I lose $100,000? Lose. So from their perspective, she doesn't survive. That is a negative $100,000 to you. What does happen if she lives? What's that to you? Basically, how much do you pay out? Well, let's ignore that part for now. We'll say how much do you pay out?
None.
0. Is everyone on board with that part?
Mm-hmm.
Okay. Now you need to find the probabilities of each of these. Do you know the probability of one of them?
Yeah.
Okay. If you know the probability of one of them, it's either one or the other. Can you find the probability of the opposite?
Yes.
Because either she does or doesn't, right? Those two things need to add up to 1 or 100%. So you know the probability that she lives. You can find the probability that she doesn't. Everybody do that. It's in the problem. Find it. Find it in the problem. Incidentally, did anybody get this? Did anybody get 9.43 E negative 4?
Yes.
Okay. So what the E negative 4 means is that we need to move our decimal place over 4 places. Should it become bigger or smaller? Smaller. Yeah, because the negative means it should become smaller. So here's a trick from one of my fabulous students in the past. They said, oh, Ms. Young, you could just do this. E negative 4 means add 4 zeros to the front. 1, 2, 3, 4. And the decimal place goes after the first 0. Because it's, it's 9 points, so it's always like, there's always a number before the decimal place. So decimal place goes after the first 0, so then this becomes 0.000943. Nifty trick, right? All right, so everybody has this table now. Now find your expected value, just like you have all the other problems. I'm not asking for the standard deviation, so you don't need your list or your calculator. Just, how do you find the expected value? Multiply every x value by its probability. How do you find the expected value? Yeah, that's how you find this. Right. Yeah. Now that you've found those numbers, find the expected value. Multiply just like yes.
Yeah, so I thought. No, you're saying you're confused. I was like, I'm really confused.
Keep going.
And then I got to that part, I was like, oh, yeah.
Without telling him, kind of.
Yeah. She was already
So on the exam, you'll have to show me what you multiplied and added in order to get credit for this. You cannot just throw it into your calculator and get a number.
Sure. I got that number.
Yeah, I know.
No, I'm like, oh my God. We got my friend was telling me, I was like, I remember, and her face was just slowly like dropped. She's like, everything, like, she like, and I was like, okay, this is bad. I feel like, yeah, it should be negative. If that's 0, you multiply that by negative 1,000. Yeah. She really lived for that.
All right, so expected value, you multiply every x by its probability. So 0 times 0.999057 plus negative 100,000 times 0.000943. And everybody got, this goes to 0, so this becomes 94.3, negative. So they pay out 94.3. So that's the expected value of their payout, right? So their total profit should be, they get, here's the thing, they get 360 no matter what. So their, the policy should be 360 minus 94.3. So all together they make 260,570, is that right? I think this is the easy way of going is finding that part first and then adding it to 360 because they get the 360 no matter what. You could incorporate it into your numbers where you have 360 if she lives and then 100,000 negative 100,000 plus 360 over there, but then you get messy numbers. And you could do it that way, but it's easier to do it this way. Because no matter what, you get the 360, right? Lives or doesn't live, you still get 360. Okay. All right, so that is the end of 5.2. Now we're going to talk about 5.3, the binomial distribution. I need a good reader. Lauren, have you read it?
Yes.
Okay. Diego read it. Alberto, you haven't read yet.
The binomial distribution, a binomial experiment is a probability experiment that satisfies these requirements. 1. Has a fixed number of trails. 2. Each trail has only 2 outcomes. 3. The outcomes of each trial must be independent of each other. And 4. The probability of success must remain the same for each trial.
Perfect, that's good. Thank you. Great, so 4 things it has to satisfy. Let's talk about the second one first. Each trial has only 2 outcomes. So, for example, flipping a coin. You either get heads or tails. I can also make anything else though, like rolling a dice. I can make it into rolling a 4 or not rolling a 4. So everybody's writing these down, right, in your notes. Bottom of page 3, bottom of the 3rd page of your chapter 5 notes. You're writing all these things, these 4 steps down here. You can make it, you pick a person, either they have brown hair or they don't, right? Or they own a dog or they don't, right? You can make anything binomial. Binomial is just, there's 2 possible outcomes. Either it is or it isn't. Now look at number 1, fixed number of trials. So you're doing something over and over again, like flipping a coin, or rolling a dice, or picking a person over and over again. But you know when you're going to stop. You know before you start, I'm only going to flip a coin 8 times, or I'm only going to roll a dice 10 times, or I'm only going to pick 14 people. You know before you start when you're going to stop. You have a fixed number of trials. 3 and 4 have to do, they're closely related. The probability of each trial stays the same. Right, so the probability of flipping a coin and getting heads stays the same. Probability of rolling a dice and getting a 4 stays the same. The probability of picking somebody and then owning a dog remains the same. So those are requirements for a binomial distribution. Has everybody written those down yet? If you haven't, then take a picture now. This is going away in 5 seconds. 5, 4, 3, 2, 1. All right, so here's a question. I have 10 marbles in a bag. 4 of them are white. I draw a marble and look at it to see if it's white or not. I do not replace the marble, I keep it. And I repeat that 4 more times, total 5 times. I repeat that 4 more times. Is that binomial or not? 10 seconds, think about it on your own. Is it binomial or not? Check the 4 requirements. No talking. Now confer with your neighbors, 15 seconds. Is it binomial or not? Those of you who are not talking, I will probably call on.
What the probability is if you take a white marble to replace it?
If you and your neighbor don't know, ask somebody else. Alberto, you know?
There is a fixed number of trials, and each trial does have just 2 outcomes. The outcomes of each trial must be independent of each other. I thought,
All right, take a look. The first one is something happening over and over again. And I know how many, let's start with number 2 actually. Is is something happening over again and that thing only has two possible options, is or isn't?
Yes.
Yes. Looking at a marble, it's either white or it's not. Good? Do I know ahead of time that I'm only going to draw a marble a certain number of times? Yes, I'm only drawing it 1 plus 4 more, 5 times total. So that the first number 1 satisfied. Then 3 and 4. Does the probability remain the same for each draw?
No.
No, because I'm not replacing it. So if I draw it, I keep the marble. The second time around, I no longer have 10 marbles. Now I only have 9 marbles. So 3 and 4 they're not met. So this is not binomial. Good? Okay. What if I draw a marble 5 times, but I replace the marble each time? I put it back each time.
Yeah.
Now it is, because remember with replacement, the probability stays the same. It's independent. Okay, so I need to give me thumbs up. Give me like thumbs up, thumbs sideways, or thumbs down. Is that how you're feeling about this? Okay. I think people are all right with this. Okay. Good enough to move on. All right, here's a notation that you will need. The first one is little p. I like thinking like a little rapper, little p. Little p is the probability of success for just one trial, only one trial. So just one flip of the coin, just one roll of dice, just one person that you select. Little q is the probability of failure for that one trial. So little p and little q, they have to add up to 1, because either you are or aren't, right? Those two probabilities have to add up to 1. So 1 minus little p is little q. N is the number of trials. In other words, how many times are you flipping the coin? Or rolling the dice, or picking a person? How many people are you picking? And then X is the number of successes in N trials. Okay, so if I flip a coin 6 times, how many heads could I get? 6 or 0, or any number in between. So my number of successes or heads could be 0 all the way up to 6. Anywhere in between that. Don't forget 0. You can always have 0 successes. All right. So the next thing you have to fill out is this big gap in there. In a binomial experiment, the probability of exactly X successes in N trials is, write it in here. Right, write it right in there. Probability of X, so this is big P. So this is the probability overall. Right, not the little p. It's the little p is just one trial. This is probability of getting this many successes. Big P. Probability of X, you're writing it right in here, is N choose X times little p raised to the power of X times little q raised to the power of N minus X. Now that you've proven to me you know how to find N choose X, we can just use our calculator to find N choose X. So I'll show you guys that in a minute. Yeah.
Just a quick question. Is it called binomial because there's just 2 outcomes?
Oh yeah, great. So yeah, I forgot to mention that. So binomial, you guys have heard like bicycle, 2 wheels. Bicentennial, 200 years, right? 2 centuries. Binomial, 2 options. Either is or isn't. You only have, it's binomial because you only have 2 possible outcomes. Either you are or you aren't. Right? It's either you're heads or you're not. Either you're a 6 or you're not. Either you own a dog or you don't. Right? So it's just 2 options. Yeah, thank you so much. So here's this probability. I'm going to show you guys a tree diagram to understand this a little bit better. Austin, go and read for me.
Say a particular couple had 3 children with a 0.6 chance of having a girl and a 0.4 chance of having a boy.
Perfect. So this would be a probability tree that we have for this. Right? First kid could be a boy or a girl. Second child could be a boy or a girl. Third child could be a boy or a girl. The probabilities for each of these are on the branches. Good? Say we want to know the probability of having exactly 2 boys. Then our success is a boy. So little p would be the probability of boy, 0.4. Which means that little q would be what? 0.6. 1 minus 0.4. Great. So again, here are our formulas. You can use either one. These formulas are exactly the same. Personally, I don't like the last one at all, but some of you folks may like. It's basically just n choose x, the formula for n choose x. You can use either one, but I prefer the top one. It's cleaner. But it's up to you. If you like the bottom one, if you found n choose x by doing that whole n factorial over n minus x factorial, over x factorial, then you can totally do that. That's fine. All right, so q is 0.6. What's our n? Number of times you're having a child? What's that?
2.
Nope. How many kids are you going to have?
3.
3 kids? What's our x? What does x stand for? I will look up the thing you just wrote down. What does x stand for? Number of successes. How many successes do I want to have? 2. 2 boys. What is n minus x? 1. What does 1 represent? The ones that are not boys, right? The number of girls. My failures, in a sense, right? Good. So for exactly 2 boys, that means x equals 2. So in this case, a boy is a success. So my n is 3. So then, if we look at these, the ones in purple are all the ones that have exactly 2 boys. All right, 2 boys and 1 girl. So that's these. It's this one. These 3. Everybody with me on this part? What do they have in common? Yeah, 0.4 squared times 0.6. Why? Because as you go along these, they all have 2, a boy, girl, boy, boy, girl. Everybody should have that. What did you get for your mean?
1.
So mu equals equal to what? 1.34. It gave us your sigma. What's your sigma? 0.96. So then you have to find your sigma squared on your own. So if you square this, it's, sigma squared would be 0.96 squared. And you folks got 0.92, I think?
Yeah.
Great. Okay, good. So you can do that on the, do that one later. You can do that on your own later, not a problem. So a reminder, the expected value or expectation is the mean. They're the same thing. So the mean you need to find by hand, right? By taking every x value, multiply by its probability, and then add them up. So let's take a look at the lab problem. I don't think it's 14. Is it 14? 5? 6? 5? Okay. Life insurance. How about a reader? Cole, go and read for me.
A 35-year-old woman purchases a $100,000 term life insurance policy for an annual payment of $360. Based on a period of life taken in the U.S. government, the probability that she will survive the year is 0.999057. Find the expected value of the policy for the insurance company.
Expected value for the insurance company. So you are the insurance company. Who knows what life insurance is? Who's ever watched a movie where the wife kills the husband for the life insurance? Right? So, in other words, if you die, your family gets paid. Right? That's life insurance. Okay, so first off, we need to figure out what varies in this problem. What are the possible outcomes of this problem? An x value, The probability of X, and you figure out what are the possible outcomes. What could happen? Yes?
Dying or not dying.
Yeah, so that she lives or not, right? Okay, but let's put the lives or not lives in terms of outcomes for the insurance company. What happens if she lives? How much do I pay out? If she lives. If she lives, I'm not giving, how much do I pay out? 0. If she doesn't live, how much do I pay out? Everybody talk to your neighbors. If she lives, how much do I pay out? I'm going to ask somebody randomly in 5 seconds. Brett, how much do I pay out if she lives? If she doesn't live, sorry.
Nothing.
Yep, and what if she doesn't live? 100,000. Okay, so we have a certain amount we need to cover today. So if you folks are on board with me and get through this faster, then we can get our class on time today. But I'm going to cover it no matter what. So let's move faster, not slower, ideally. If she lives, they pay out 0. If she does not live, they pay out 100,000. Oh, do they get it or do they pay it? If you're the insurance company, do you get it or do you pay it? Pay it. So is it positive or negative? Negative. Okay, what's probability? Do I know either of these probabilities?
Yeah.
Yes, which one do I know? Lives. What's that? 0.999057? Can I find the other one? Yes, find the other one, and then find the expected value. 2 minutes, and then we'll go over it.